Look up on a winter night toward the constellation Orion and find the reddish point of light marking his shoulder. You have probably seen it 1,000 times without knowing its name. It is called Betelgeuse, and the light landing in your eye tonight left that star around 7 centuries ago when the cathedrals of Europe were still under construction, which means something quietly unsettling. Betelgeuse might still be up there, burning as it has for millions of years, or it might have already torn itself apart in one of the most violent events the universe permits, sometime in the human Middle Ages, and the news of its death is only now crossing the last stretch of empty space toward us. We cannot know yet. When you look at Betelgeuse, you are not looking at a star. You are looking at a message, 700 years in transit, and you have no way of telling whether the sender is still alive. Betelgeuse is a red supergiant, and it sits closer to the end of its life than almost any bright star you can see with the naked eye. Its color is the first clue. Our sun burns yellow white at a surface temperature near 5,500 degrees Celsius. Betelgeuse glows a deep sullen red, its surface a comparatively cool 3,200 degrees. In a star, red does not mean gentle, it means swollen, unstable, and running low on time. The distance is genuinely hard to pin down, and that difficulty is itself part of the story. Betelgeuse is so large and so churning that its edges are blurred and its parallax wobbles in ways that resist clean measurement. The current estimates place it somewhere between about 500 and 700 light-years away, with recent work favoring the higher end. Astronomers will tell you plainly that the number still carries real uncertainty. What they agree on is the mass. Betelgeuse holds somewhere between 16 and 19 times the material of our Sun, and that single fact has already sealed its fate. In the universe, mass is destiny. A star this heavy cannot die quietly. Its name comes down to us through a long chain of translation and mistranslation from medieval Arabic, its meaning worn smooth by centuries of retelling. The astronomers who cataloged it never imagined we would one day watch its surface boil in real time. But we can. And its size is the reason. Almost every star in the night sky is a point no telescope ever built can show you its disk. The stars are simply too far and too small on the sky, and they stay pinpricks no matter how much glass you aim at them. Betelgeuse is one of the rare exceptions. It is close enough and vast enough that our best instruments can resolve it into an actual surface, a mottled orange globe with bright cells of rising gas larger than the orbits of planets. To feel why that is so strange, picture the scale. If you shrank the sun to the size of a basketball and set it on the ground, the Earth would be a peppercorn rolling about 30 paces away. On that same scale, Betelgeuse would not fit inside a football stadium. It would rise into the sky like a hot air balloon, the width of a city district, dwarfing the block you were standing on. Now put it where it would truly matter. Take Betelgeuse and drop it into the center of our solar system, in the place where the sun now sits. Its surface would swallow Mercury. It would swallow Venus. It would swallow the Earth, the oceans, every mountain and every city, the whole of the ground beneath you, without so much as a ripple. It would swallow Mars and keep going, out past the inner planets toward the asteroid belt. By some of the larger measurements, its glowing edge would reach nearly to the orbit of Jupiter. If you were standing on Earth in that arrangement, you would not be looking up at a star. You would be buried hundreds of millions of kilometers deep inside one, somewhere in its cooler outer layers, long since vaporized. That is the first thing to understand about Betelgeuse. It is not a bigger version of the Sun. It is a different order of object, a star so distended that a single one of its convection cells could hold our entire inner solar system. And its size is not even the part that should frighten you. For most of human history, every star was nothing but a point of light with a name attached. Their true sizes were pure guesswork. Then, in December of 1920, on the mountaintop of Mount Wilson in California, two astronomers named Albert Michelson and Francis Pease fitted a long beam interferometer across the front of the great 100-inch telescope and turned it on Betelgeuse. By carefully measuring how the star's light interfered with itself, they did something no one had ever done. They measured the physical diameter of a star other than the Sun. The number they arrived at was so large it was hard to believe, a star hundreds of times wider than our own. It was the first hard proof that supergiants were real and not just bright. Betelgeuse kept its place at the frontier. In the mid-1990s, the Hubble Space Telescope returned the first direct image of the disk of any star beyond the Sun, and the star it chose to photograph was this one, its surface marked by a single vast bright spot larger than the Earth's entire orbit. Since then, arrays of linked telescopes have watched that surface change from month to month, its enormous cells of gas swelling and sinking like a pot at a slow boil. We are the first generation of humans who can look directly at the face of another star and watch it move. And what we are watching is a star in the last act of its life. There is a way to feel that final ferocity in numbers. Betelgeuse pours out something like 100,000 times the light of our Sun. If it were somehow set where the Sun is, its glare alone would fill a wide arc of the daytime sky, and the heat would boil the oceans away long before anyone worried about being swallowed by its edge. This is a star radiating a human lifetime's worth of the Sun's output roughly every few hours. That prodigious burning is exactly why it is dying so fast. Every star is a war between two forces. Gravity pulls relentlessly inward, trying to crush the star into a point. Fusion in the core pushes outward, the pressure of nuclear fire holding the collapse at bay. For most of a star's life, these two forces balance, and the star is stable. That balance is what a star is. But fusion runs on fuel, and fuel runs out. Our Sun has burned hydrogen into helium for 4.5 billion years and will keep doing so for 5 billion more. Betelgeuse, far heavier, has lived fast and is nearly spent. In perhaps only 8 to 10 million years, a mere flicker in cosmic time, it has already exhausted the hydrogen in its core. Now it burns helium. When the helium is gone, it will burn carbon, then neon, then oxygen, each stage hotter, each stage shorter than the last. Here is the terrible acceleration hidden in that list. Hydrogen burning lasts millions of years. By the time a star like this reaches the burning of neon, that stage may last only about a year. Oxygen burning, a matter of months. The final stage, the fusing of silicon into iron, lasts about a day. The star spends its whole existence building toward an ending that arrives at the very last over a single afternoon. And iron is where the war is lost. Every fusion reaction before iron releases energy, feeding the outward pressure that holds the star up. Iron does not. Fusing iron consumes energy rather than giving it. The moment the core becomes iron, the fire that has resisted gravity for millions of years simply stops paying out. The pressure vanishes. And gravity, which has been waiting patiently the entire time, finally gets everything it has ever wanted. We do not know which stage Betelgeuse is in right now. It could have millions of years of core evolution left. It could, by some estimates, be in its final phases already, the countdown measured in a human lifetime or less. The honest answer from astronomers is that Betelgeuse will explode sometime within roughly the next 100,000 years, which, on a cosmic clock, is essentially now, and on a human clock could mean tonight or 10,000 generations from now. That uncertainty is not a gap in the science. It is the nature of standing outside a process this slow and this final. For a few months, we thought we might be about to watch it happen. In late 2019, Betelgeuse began to fade. This was not entirely unusual on its own. The star is a known variable, brightening and dimming on overlapping rhythms as its bloated surface pulses. But this dimming did not stop where it usually does. Through December and into January of 2020, Betelgeuse kept falling until it had lost roughly 2/3 of its light and dropped out of the ranks of the brightest stars in the sky. Anyone who knew Orion could see it with their own eyes. The shoulder had gone dark. Astronomers around the world turned their instruments toward it, and a quiet electric question spread through the community. Was this it? Was the collapse beginning? It was not. When the great telescopes resolved that fading surface, they found the answer, and it was in its own way just as remarkable. Betelgeuse had not begun to die. It had belched. A vast plume of gas had risen from one of the star's enormous convection cells, drifted outward, cooled, and condensed into a cloud of dust. That dust hung between us and the star's southern face like soot on a lamp, dimming a huge fraction of its light. A cooler patch on the surface likely deepened the effect. Within months, the dust dispersed, the star brightened again, and the shoulder of Orion returned to the sky. The great dimming was not a false alarm so much as a rehearsal. It taught us that Betelgeuse is restless enough to fool us, that its surface can throw off a planet's worth of material in a single event, and that when the real ending comes, we may not recognize the first sign of it any more than we recognized this one. The star gave us a warning that was not a warning and then went quiet again. The question it raised did not go away. It only changed from, "Is this the end?" to "Then when?" When the end does come, it comes faster than thought. At the instant the iron core forms and the outward pressure fails, the center of Betelgeuse collapses. An object larger than the Earth falls inward in less than a second, the infalling matter reaching a quarter of the speed of light. The core crushes down until its protons and electrons are jammed together into neutrons, and matter reaches a density so extreme that the collapse suddenly halts against a wall of pure nuclear resistance. The outer layers of the star, still rushing inward, slam into that unyielding core and rebound. A shock wave tears back out through the star, and in a storm of ghostly particles called neutrinos, more energy is released in a few seconds than our sun will radiate across its entire 10 billion-year life. The star is blown apart. What we see from Earth is the flash. But the flash is not the first thing to reach us. Those neutrinos born in the collapse barely interact with matter, and they pour out of the dying core hours before the light of the explosion claws its way to the surface of the star. They cross the 700 light-years and arrive first. Deep underground, in tanks of water and liquid built to catch such ghosts, detectors on Earth would register a sudden pulse from the direction of Orion, and for a few short hours, the world would hold a secret the sky had not yet revealed. Betelgeuse would be dead, and only a handful of instruments buried in the rock would know it, waiting for the light to confirm what the neutrinos had already whispered. And here, the numbers become difficult to hold in the mind. A supernova at Betelgeuse's distance would blaze in our sky at a brightness rivaling the moon. Not a bright star, a second light in the heavens, a fierce blue-white point casting shadows on the ground at midnight, visible in full daylight for weeks, hanging in the sky for months before it slowly fades over the better part of a year. Every human being on Earth would be able to see it, no telescope required. You would walk outside, and there, in the shoulder of a familiar constellation, would burn a new thing that had not been there the night before. Now recall where we began. Betelgeuse is around 700 light-years away. The explosion we are describing is not a future event in the simple sense. If Betelgeuse blew apart 3 centuries ago, its light is still crossing the dark toward us, and we are living in the last quiet years before it arrives, unaware. The flash you might see on some ordinary future night would be the delayed echo of a death that already happened in a star that has not existed for hundreds of years. We are not waiting for Betelgeuse to explode. We may only be waiting to find out that it already has. Step back far enough, and the true scale of what a supernova is becomes almost unbearable. For a few weeks, a single exploding star can shine brighter than every other star in its galaxy combined. Betelgeuse belongs to the Milky Way, a wheel of a few 100 billion suns. At its peak, a core collapse supernova can briefly outshine that entire assembly, hundreds of billions of stars eclipsed by the light of one of them dying. Astronomers in distant galaxies see these flashes across billions of light-years, single points of light that rise for a moment to the brightness of 100 billion suns, then fade. Each one is a star like Betelgeuse, somewhere, ending. And something is left behind. When the outer layers blast away into an expanding cloud of glowing debris, seeding space with the oxygen, the carbon, the iron that will one day become planets and possibly life, the crushed core remains at the center. For a star of Betelgeuse's mass, that core most likely becomes a neutron star, an object about 20 kilometers across that contains more mass than the Sun. Hold that against something you can picture. A neutron star packs the mass of a star into a ball the size of a city. Its matter is so dense that a single sugar cube-sized piece of it would weigh about as much as a mountain, as much as all the humans who have ever lived compressed into something you could close your hand around. It spins, sometimes many times a second, dragging fierce magnetic fields around with it. From the swollen red giant we can see with our naked eye tonight, a body wider than the orbit of Mars, gravity will, in the end, wring out a dark, dense cinder the size of a coastal town. That is the ladder this star is climbing down. From something larger than a solar system to a point of crushed matter you could drive across in 20 minutes, if anything could survive standing on it. There is one more thing to understand before we ask whether we are safe, and it changes what a supernova means. The explosion is not only an ending, it is also the single most important act of creation in the universe. In the ordinary life of a star, fusion can only build elements up to iron. Everything heavier, and much of what is lighter, is forged in the extreme heat and crushing pressure of the collapse and the blast itself, then flung out across space in the expanding wreck. The oxygen in the air moving through your lungs right now was made in the heart of a massive star. So was the calcium holding your bones rigid, and the iron that colors your blood red. When Betelgeuse tears itself apart, it will not simply die. It will scatter a fresh cloud of the very stuff that planets, oceans, and living bodies are built from, out into the dark, where in time some of it may gather into new worlds. Every supernova is a grave and a cradle at once, and humans have stood beneath this before. In the year 1054, astronomers in China and across the Islamic world recorded a new star that appeared without warning near the Horn of Taurus. It was bright enough to be seen in broad daylight for over 3 weeks, and it lingered in the night sky for nearly 2 years before fading. Today, we point our telescopes at that same patch of sky and see the Crab Nebula, a still expanding cloud of shredded star with a spinning neutron core at its heart. The wreckage of the explosion those observers watched with naked eyes. 5 centuries later, in 1572 and again in 1604, the astronomers Tycho Brahe and Johannes Kepler each recorded a new star blazing where none had been, observations that helped break the ancient belief that the heavens never change. Those were the last supernovae seen with the unaided eye anywhere in our galaxy. The most recent was more than 400 years ago. On the timescales that govern the lives of stars, the Milky Way is quietly overdue for another. Betelgeuse is the nearest strong candidate we can see. When it goes, it will be the first time in the age of telescopes, cameras, and satellites that our species has watched a nearby star die with its full attention turned upward. It is a fair question, and the honest answer is yes. A supernova is one of the few events in nature capable of sterilizing worlds. If Betelgeuse were close, within perhaps 30 light-years, its radiation could strip Earth's ozone layer and bathe the surface in harm. But Betelgeuse is not close. At around 700 light-years, it sits roughly 20 times farther than that danger zone. When it explodes, the flood of radiation and high-energy particles will have thinned across 7 centuries of empty space to something the Earth's atmosphere can shrug off. There may be a faint, harmless rise in cosmic particles. There will be no extinction, no scorched sky, no catastrophe. The rotation axis of the star, along which the most focused energy would travel, does not appear to be aimed at us in any case. What there will be is a spectacle without equal in recorded history. For the length of time it burns, our ancestors' descendants will share the daytime sky with a dying star, bright enough to read by at night, bright enough to cast a second set of shadows. Every civilization on Earth will look up at the same new light. It will be, for a season, the most watched object in the sky. And then it will slowly dim, and the shoulder of Orion will simply be empty. A gap where a star stood for all of human history until the moment we happen to be alive to see it go. We are, in that sense, extraordinarily lucky and extraordinarily safe at once. Close enough to witness one of the universe's great violences in full daylight, far enough that it can do nothing to us but take our breath away. So we are left with the strange arithmetic of light and distance. The Betelgeuse in your sky tonight is a portrait of a star as it was 700 years ago. What it is doing right now at this exact moment is a fact that has not yet reached us and cannot for a long time. It may be burning steadily with 100,000 years of slow dying still ahead of it. It may already be a swelling cloud of debris wrapped around a spinning cinder, its final flash still somewhere out in the dark between the stars, closing the distance year by year, patient on its way. We stand at the near end of that long line of light, on a small world, watching a shoulder in a winter constellation and unable to say whether the thing we are looking at still exists. That is what it is to look out into the universe. Not to see what is, but to see what was, and to wait. Somewhere out there, the answer is already on its way toward us. It is only a matter of which night we happen to be looking up. The universe is mostly silence and dark. New cosmic documentaries every week. Subscribe to stand at the edge of the cosmic abyss